almost everything we've done with rational expressions so far, we've looked at kind of the regular fraction with numbers equivalent first. And now that we're looking at solving rational equations, we're going to start the same way. Now, if we have this equation, one way that we could solve it is by, well, we see fraction addition. And so our first instinct might be to make a common denominator. So we could multiply this and this both by one of those magic ones to get a common denominator between these two. And then we would have that equal to 5/12, and we could cross multiply this. This is a lot of work. It turns out that there's a much easier way to do this. And that is, let's look at all of the denominators in here, 4, 18, and 12, figure out what their least common denominator would be. In this case, that would be 36. And what we're going to do is multiply every term in this entire equation by 36. So let's see what happens when we do that. 36 times 1/4 is 9. If we multiply 36 times x over 18, the 36 and the 18 would cancel and just give us 2, and then 2x. And similarly, when we multiplied by the last term, the 36 and 12 would cancel, give us 3. 3 times 5 is 15. And suddenly that leaves us with a much easier equation to solve. And so the lesson from this is that when we have equations with fractions, or what we know now to be rational equations, instead of making a common denominator, the best way to go is to figure out what the common denominator would be for all of the denominators in the whole thing, and just multiply through by that and get rid of the denominators entirely. So let's look at a few examples of rational equations, and we're going to apply this technique. For this first one, I'm going to use just this slight visual thing that I've used before, just to make it more obvious that that's a factor, that's a factor, that's a factor. We'll do the same thing here. These denominators don't have any factors in common. So if we're looking at what the common denominator or least common denominator would be for this whole thing, we need an x, and we need an x plus 1. And what we're going to do is take this thing that would have been the least common denominator, and we're just going to multiply that by each term. All right, so when we multiply by 2, of course, nothing cancels because there is no denominator there. So we have that. When we multiply by this term, both things cancel. We've got an x, we've got an x plus 1. So everything cancels, and we just have -1. When we multiply by this last term, the x plus 1s will cancel, leaving us with 3x. So let's multiply this out a little bit and see what this is actually leaving us. And what we need to do at this point is recognize this is a quadratic equation. And we've got some techniques for solving those, basically all of which start by getting one side equal to 0. So I'm going to subtract 3x from both sides. 2x squared minus x minus 1 equal 0. Now, we do have, if we're looking to factor this, we do have a leading coefficient in a that's greater than 1. But these numbers are so simple, I think that just with a little trial and error, we should be able to factor this, because after all, there's not too many choices for what these can be. And there's not too many choices for what these can be. They both have to be 1. It's just a question of the signs. What we're going to need here is a minus 2x and a plus 1x. So that'll be a plus 1x. That'll be a minus 2x. So let's make sure that'll be 2x squared plus x minus 2x. So that's good. And then minus 1. And so I can just come up here and find our actual solutions. X minus 1 equals 0. So 2x equals -1/2, and x, oops, I got a little ahead of myself there. 2x equals -1, x equals -1/2, and x equals 1. One thing that we always need to check when we're dealing with rational equations is we need to make sure that none of the answers that we get would produce division by zero. In other words, that none of them are restricted values if we're thinking of it that way. And we can look here and see that as far as restricted values, if x equaled 0, that would be a problem. And if x equaled -1, that would be a problem. But neither of those came up in our solutions. So the two answers that we got are, in fact, the correct ones. And they both work. So let's do this with a couple more questions here. All right. We know the deal with rational expressions that if you see anything that's factorable, that's just the first thing that you do. So we'll go ahead and factor this one. And like a lot of other questions that you see on this topic, most of the questions you get, there's going to be stuff that works out. Like it's not a coincidence that this factors to the term that you see here and the term that you see here. If you didn't have things like that that matched up, it just wouldn't be a very good or useful question. Okay, we know our technique. We're going to multiply by whatever the least common denominator would have been. So when we look at the factors here, we need to account for an x plus 2. We need to account for an x plus 3. We've already got an x plus 2 accounted for, so this one's good. We've already got an x plus 3 accounted for, so this one's good. Okay, so that's what we're going to multiply through by. Let's do that. When we multiply by this first term, the x plus 2's would cancel and leave us with x times x plus 3. When we multiply by the second term, both of those would cancel with both of those, leave us just plus 2. And when we multiplied this third one, the x plus 3's would cancel and leave us with 5 times x plus 2. Okay, so we've got our usual simplifying to do here. Again, we recognize that it's a quadratic, so we need to get one side equal to 0. X squared. So let's see, plus 3x minus 5 minus 2x minus 8 equals 0. That one will factor easily enough. So we'll do x minus 4 and x plus 2 equals 0. X equals 4 and x equals -2. Again, we need to check to ensure that none of these are values that would produce division by 0. So let's see, -2, well, you might notice we've got that and we had an x plus 2 there. This is going to be a problem, right? Because if we put in x equals -2, this first term would be -2 over -2 plus 2. That would be -2 over 0. We can't have division by 0. So x equals -2, that's not actually a solution. X equals 4, that one's fine. We don't have any factors here that would produce x equals 4 as a restricted value. And so in this case, we got 2 answers from our algebra, but when we went back to check, only one of them is an actual solution. You always need to check both of the answers that you get, or however many answers that you get. They could all work, none of them could work, some of them could work. We always need to check all of them. All right, so let's do one more of these. Same idea. We've got something we can factor if it's a rational anything. That's really where we're going to start, is by factoring. So that'll be x. Again, you can almost sort of predict how this is going to factor, because if it didn't factor this way, it wouldn't be a great question. So this will probably be pretty similar to the last one, but we'll see. Looking for what would be the greatest common denominator, we need to account for an x plus 1. We need to account for an x minus 3. When we get here, both of those are already accounted for. So we'll do our process of multiplying through by what would have been a common denominator. First term, the x plus 1s would cancel, leave us x minus 3. Second one, the x minus 3s would cancel, leave us x plus 1. The last one, both of those would cancel with both of those and leave us 4x. So a little algebra to do here. We want, again, it's a quadratic. We want that side to equal 0. See if I can do this all at once here. So start with the x squared. We'll have x plus x is 2x minus 4x is minus 2x. And then minus 3 equals 0. Factor that. We'll have x minus 3, x plus 1. You may notice something's going on here, that this expression is the same as this one. See if we can make a prediction about where that's going to lead. Here are the two answers that we get. But if we think back here, well, if we set this equal to 0 to find our values that are disallowed, because we can't have division by 0, well, these are the two things that we're going to get. X equals 3 and x equals -1. Both of these are going to produce a 0 in this denominator. And for that matter, 3 is going to produce a 0 there, and -1 is going to produce a 0 there. So neither of these solutions actually works. We always have to check all the solutions that we get. And in this case, this one has no solution. That'll happen sometimes.